Hi, welcome to the exercise of the lecture 7, cross-aldyl reaction and Michael addition. We can start with exercise 1 that gives the reaction products of the following reactions. We have this, and we add what we have to know here is that this is an alpha-beta unsaturated ketone, a conjugate ketone. That means that this will be the electrophile. Remember, we have a density negative charge in the oxygen, density positive charge in this carbon, density positive charge in this carbon, and we have a nucleophile that is the sulfur, the thiol compound, the thiol. We'll attack here. We generate this compound, and then this can take the hydrogen to form this final compound. Okay? Next one, we have again an alpha-beta unsaturated ketone, and we do the same. We know that this position is electrophile, okay, and we add now a secondary amine. What will happen is that the pair of electrons of the nitrogen will attack the beta position. The double bond will come here, and what we get okay, and then this negative charge take the hydrogen. Pair of electrons are going to the nitrogen, and what we have is the addition of the nitrogen in the beta position. Next one, we have this compound, and we add benzyl oxide plus catalytic amount of soluble benzyl oxide. Okay, what will happen? Remember that is the anion, the alkoxide, which will attack the beta position. Again, this is a lambda positive. We generate this compound, and then this reacts with one molecule of the benzyl alcohol to obtain the final compound and the benzyl oxide to do a new reaction. Okay. Okay. Go for the next one. The next one, we have this compound, where we have this molecule that we have two beta positions. Okay? And we add primary mean. What will happen is that the pair of electrons of the nitrogen will attack the double bond as before. We generate this intermediate. Again, what could happen is that this negative charge can take one of these protons. You can do it in one step, you can do it in two. This is the same, okay? Basically, in order to do it a little bit fast in the programs, I do it in one step, but if you want to do it in two steps, you can check the notes where I explain how to do it. Okay, we generate this compound. Okay, and now what could happen is that we still have a pair of electrons in the nitrogen, will attack the other beta position. Okay, and what we have now is that we have this reaction, and again we can take the hydrogen, and what we get is this final compound. Okay, the only that I did is twice the Michael addition. Okay, then we're going to go for the last example. We have this compound. Again, this is an alphabet unsaturated compound. We have, remember that if we attack with a nucleophile, what will happen is that we'll go to the beta position. And then we add an alcohol in acid media. What will happen? Well, if we are in acid media, remember what we do is to obtain this compound, we protonate the carbonyl of the alphabet unsaturated compound. And remember, when we protonate a carbonyl, this carbon becomes more electrophilic. And because this system is conjugate, this carbon also becomes more electrophilic. You can do the resonance structures and check that this position will become more electrophilic, and is electrophilic enough in order that this alcohol, that is a very weak nucleophile, attacks here. What we have is okay, we have this compound, and then this negative charge can take the hydrogen. Okay, and then we lost a proton in order to deprotonate the deprotonate the carbonyl group to get the final compound. Okay? Okay, the exercise number 2 is this, put the mechanism of the last two reactions, but I put the mechanism of all, that means that it's already done. Okay? Next one is give the exercise number 3. Give the reaction products of the following. Okay, we have this compound again. This is an alpha-beta unsaturated ketone. Okay, remember. And the pair of electrons of the nitrogen will attack the beta position. The pair of electrons will go to the carbon alpha. And what we get is this intermediate, like before. And now this anion will take this hydrogen, and we got the Michael product. Okay, second example, we have I will draw it like. Okay, again, this is the same concept. We have a density negative charge here, density positive charge here, and because this is conjugate, this is the same P system, we have a density positive charge on the carbon in the beta position. We add this thiol, and what will happen is that the thiol will attack the beta, the pair of electrons will go to the alpha position, and what we get this. Next step, the negative charge will take the hydrogen, the pair of electrons will go to the sulfur, and we get this final compound. Okay? That means it's the same mechanism that we did before, but now with an ester. But this doesn't change the polarity of the carbons. Okay? Now exercise number 4. In the exercise number 4, this says, give the mechanism and write the products of the following reactions. Okay, we have here a ketone, we have here an aldehyde, and they say that we add base. Okay, first of all, we have to define which is the enolate and which is the electrophile, or which is the nucleophile, which is the electrophile. We can form the enolate here because we have a hydrogen here, we can form the enolate here. But in this compound here is a hydrogen, we cannot form any enolate, and this position doesn't have hydrogens. That means when we add a base, what is happening is that the base is taking one of these protons, which is the same, are symmetrical. Okay, and we generate the enolate. Right? When we have the enolate, this enolate will attack the electrophile, and we have two carbons that are electrophile. This, that is the ketone, and this, that is the aldehyde. Which is more active? I told you that aldehydes are always more reactive than not ketones. That means that this enolate will attack the aldehyde. The pair of electrons that are forming the carbon double bond oxygen are going to the oxygen. And what we get oxide, and then when we protonate, we get the aldol product. Right? Okay. Always we have to determine before we talk about the reaction who is forming the enolate and who is the electrophile. Okay, then the last one. We have this compound, this ketone plus this aldehyde. But now we are in acid media. What is happening? Well, we know that if we are doing an aldol reaction in acid media, the first thing that we need to do is to form the enol, and in order to form the enol, we need to have a hydrogen in the alpha position. The same thing for the enolate. If we don't have a hydrogen in this position, we cannot form the enol. Here we have one, but in this compound here is a hydrogen, that means not, and this position doesn't have any hydrogen. That means that the only enol that we can form is this. Okay? Now we have to find the electrophile. The electrophile is the protonate form of the carbonyls. That means that we have two possible enolates. Okay, the protonated ketone or the protonated aldehyde. Why is protonated? Because we are in acid media. Which will be more active? Well, we follow the general rule that aldehydes are always more active than not ketones. What is happening is that this nucleophile will attack the protonated form of the aldehyde, and what we will get, if we do it well, the pair of electrons of the oxygen are forming the double bond, okay? And then we lost the hydrogen. Remember that we don't like charges in our final product. We lost a proton, and what we get okay? We get this final product. If you have if you don't understand how it's working or why I get this product, one thing that is very useful is to use colors. In the video, the blue color is not very well seen, but I will try to do it. If we are doing this reaction, okay, we have the enol in blue, and we can numerate. This position I will say that is 1, this 2, 3. Okay, and this is reacting plus the red one that will be the aldehyde. And I do the same. I numerate, I put the 1 in this carbon, the 2 in the carbonyl, and the 3 in the hydrogen. What is happening is that the carbon free, the blue free, is attacking the 2 red, and the double bond that is forming the 2 oxygen bond is going to the oxygen. And what I get is, I start drawing this, okay? Okay, Okay, 1, 2, 3, I draw all the carbons. Okay, and then between 3 and 2 I am doing a bond. This is the new bond that I am forming in black. And then I get the OH here, the hydrogen and the phenyl. Okay, if I numerate this 1, the 2 carbon and the 3 hydrogen. Okay, and here I have, sorry, I have a proton here. Okay, and then in order to get the N, I only lose a proton. Okay, on this way you can check if you forget an atom or not. Okay, it's only a tip, could seem stupid, but a lot of times it's very useful if you don't have enough experience doing this type of reactions. Okay, and that's all for the exercise of lecture 7. See you in the lecture 8.